Alrighty guys, so we're going to add to our notebook again, graphing in factored form. We're going to do that on pages 33 and 34. So if you're going to set those up like I have them set up, what you're going to be looking at on page 33 is just a little graph sheet of paper here where we're going to do some extra examples, again, probably in a separate video. And then on 34, we'll have our form at the top and our book towards the bottom, and then you're going to want a little space right here to write out those instructions. So actually this like folded cockeyed, I gotta fix it. I can't. There we go. Okay, let's get started. So our final form here, factored form, is so great. I love it, but it does graph very differently than all of our other graphs. One thing that it does still have in common with all of our other forms is our A value is still here and it's still slope, okay? And I say that slope in quotes because, as always, this slope, we can only do it once. We can't continue to do it because we don't have a line on either side. We have this curve. And then also, we do it slightly differently. We take whatever the number is and put it over 1. So if it's that fraction thing, you move up the little bitty fraction, but you always move over 1, okay? Now the interesting thing is M, N, R sub 1, R sub 2, P, and Q, whatever you call these letters here, when you are in factored form, those letters there are very nice because it actually gets you 2 points on your graph. That's great. Like compared to the other ones, you could only get 1 point on your graph. Like vertex form, you could only get the vertex without doing any math. Standard form, you can only get the y-intercept without doing any math. But this one, it's great. You get 2 points without doing any math. They are your x-intercepts. So this is one x-intercept and this is another. And so kind of the way that we write it is because they are x-intercepts, p comma 0 and q comma 0. Big old note about these, because of those negative signs in front and because whenever I take stuff out of parentheses, they are going to change signs. So they will be opposite of what you see. So again, it's super nice. You get 2 great points to plot on your graph. And then we have our slope. There's also that other sneaky way that we talked about, finding the y-intercept quickly, which is nice, but we're still kind of missing that most important point, the vertex. So we do need that. So let's talk about our steps for graphing success, because we can get it fairly easily. So steps for graphing success. Now, if you think about the other ways we graphed, it was always the same. Find the vertex, use your slope, do the y-intercept. Unfortunately, that's not the case here because I don't have my vertex. We're not going to be able to find that first, okay? So the first step we want to do this time is use those things that are easy to grab from my equation, and we're going to plot our 2 x-intercepts. Easy. Second thing we did, if you remember yesterday when we were doing that activity, or earlier when we were doing that activity, once you have your x-intercepts, because a quadratic is symmetric, you can now sort of count in until you meet in the middle, and the middle is where our axis of symmetry is. So kind of step 2 is we find the axis of symmetry by counting to the middle. Now, I know that not everybody likes to just count and find a thing. Some people really like to have a formula. There kind of is a formula for this. We take our x-intercepts, p and q, add them up, and take half. And that's how we get our axis of symmetry. Now, the super nice thing, kind of in addition to this, is once you have your axis of symmetry, you have part of your vertex. So vertex is at this point that we found, either by counting to the middle or doing this little baby formula here, and then to find the y value when we want to plug it in to our equation. So after we sort of find our x-intercepts, we get to our vertex after that. Third thing, once we have our vertex, we can use A as slope once. But truly, once you have your x-intercepts, and you found your vertex, boop, you'll be able to see your parabola pretty clearly. So using the A as slope is kind of just bonus to make your parabola look even nicer. Another bonus point that we can do is find the y-intercept by putting 0 in for x. And some of you noticed that yesterday, what this looks like is we really end up doing A times P times Q. Because like the x's just go away. So that's kind of nice. And yeah, then you'll have a really nice looking graph. Again, kind of step 3 and 4 are extra here. So let's try some. So when we are in intercept form, our x-intercepts are kind of the opposites of the numbers in parentheses. So like p comma 0 and q comma 0. My axis of symmetry, we can count to the middle, or we can use that little formula, p plus q over 2, because really to find a middle, that's like finding an average, and that's what I'm doing here. I'm adding up the two x-intercepts and taking half, because there are 2 of them. My vertex is going to be at that x value, and then I'm going to plug it in to get the y value. And our y-intercept, we're going to put 0 in for x. And kind of what ends up happening is we end up doing A times P times Q. So kind of confusing with lots of letters and stuff. Let's do it with numbers and stuff. So again, kind of part of the trick here is knowing what form you're in. And I feel like I can know that I'm in intercept form because I have 2 sets of parentheses. Yeah, I feel like that's kind of the best way. Also, you have 2 x's, and kind of it seems like I don't have any x squareds, but like x times x is x squared. So it's kind of 2 parentheses, 2 x's. Those are good ways to know. And so we can kind of go through and identify our A, P, and Q. Remember, when I take stuff out of parentheses, we're going to have to make it opposite. And so that means my x-intercepts are -1 and +3. So we can plot those right now. -1, +3. Then we can kind of just do to the middle, which is 1. But just to kind of show you how that little formula works, if I take my -1 plus 3, my x-intercepts, and divide by 2, we end up with 2 over 2, which is 1. Okay, I just think it's easier to count, but sometimes we forget to like that step because we're not like doing math, we're just kind of counting. So it's kind of nice if you have a formula for some people. So my vertex, I know, is at 1 comma something. It's either going to be down here or up there. I feel like I kind of know it's going to be up there because this parabola is pointing down. But to find that y value, we're just going to plug in the 1 for x. So we'll have -2 times 1 plus 1 times 1 minus 3. And we want to do what's in parentheses first. So here we'll have a 2. Here we'll have a -2. And now all these are just smushed together. So you're really just multiplying all of them. So negative times negative is an overall positive. And then 2 times 2 times 2 is 8. So we're at 1 comma 8. I can see right now that my parabola is opening down. I also knew that because my slope was negative. Also, my slope to 1 point is -2, so we can now use that to get another point. And then I can flip it over, put it on the other side. And now I can also kind of see that my y-intercept already is found for me. But like if I had plugged in 0, or if I multiplied A times P times Q, I end up with 6, which is what I had. So parabola, cute. Let's try another. Now example 2 here, it's kind of like low-key in factored or intercept form. Because it kind of seems like I don't have two sets of parentheses, but really what's happening is that that middle one is like at x minus 0. And I don't really need a 0, so I kind of just smushed it up. So that's why I mentioned two x's, not necessarily two parentheses, is kind of the way to go here to notice if you're in factored form versus like vertex form or standard form. So kind of keeping that in mind, my a value is 2. The first x-intercept is 0, and the second one is 4. So because I know my x-intercepts are at 0 and 4, we can plot those points there. To find my axis of symmetry, I'm going to count until I get to the middle, which is at 2. Or we can do that formula again where I add these two and take half. Still 2. The vertex is going to be at 2 comma something, and to figure out that something, we're going to plug the 2 in for x. And so we end up with 2 times 2 times negative 2 for negative 8. So on my axis of symmetry, we're going to plot that vertex down here at negative 8, which I can see now that my parabola is going to have to reach up to get to those x-intercepts. So we are opening up. Also, I kind of knew that because we were positive. My slope to one point is 2. So from here, I can go up 2 over 1. And I can flip it over and put it on the other side. And then my y-intercept is when I plug in 0. But I kind of think I already have that point. Like 0 comma 0 is right here. So again, I sort of don't get an extra point, but that's okay. We still have 5, and we could still see our parabola. Cool. Next, write a quadratic function in intercept form. So kind of going backwards now. Okay, so we're looking at our parabolas, and we want to write them out in factored form. We could also write them out in vertex form, but the reason that we wouldn't want to here is because they didn't tell me where the vertex is. And it kind of also looks like it's not at a super nice point. So looking at this graph here, I can see that my x-intercepts are at 1 and 4. And so like if I think about writing my equation so far, I have a parenthesis x minus 1, x minus 4. The trouble is I need the a value, and I can't count the slope unless I count it from the vertex. And again, I don't know the vertex. But they are giving me this other point at 2 comma negative 6, which 2 comma negative 6, I can put the 2 in for x and the negative 6 in for y, and I'll know all the numbers aside from a. And so then I'll be able to figure out what a is. So we're going to plug in negative 6 for y. Don't know a, I'm trying to figure it out. And then x is 2, minus 1, and 2 minus 4. So over here, if I simplify what's in parentheses, 2 minus 1 is 1, 2 minus 4 is negative 2. And so I kind of end up with, on this side, boop, 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 negative 2 smushed up against an a, so it's like negative 2a. And then we're going to solve for a by dividing that away. And so a is 3. And so now that I know that, I can rewrite my equation with my a value filled in. So 3 parenthesis x minus 1, x minus 4, because those were my x-intercepts. Kind of clever. Okay, so looking at this next one here, I can see my x-intercept at negative 3 and 0. I can't see my vertex. That's why I probably don't want to write it in vertex form. But I am going to need another point to be able to find my a value. So like we got x minus negative 3 and then x minus 0. And so then they're giving me this other point right here at negative 6 comma negative 6. So we can plug those in for x and y so that we can solve for a. So negative 6, a parenthesis negative 6 plus 3, negative 6 minus 0. And so here we have negative 3 smushed up against a negative 6, which all of this stuff is being multiplied. So really what I have here is negative 6 equals 18a. And so to solve for a, we're going to divide by 18, which means that a is negative 1/3. Which that does make sense because this graph is like wider and this is like a wide number. And the 3 over here makes sense because we're pointing up and it's skinnier. So like I feel really good about all this. So y equals negative 1/3 parenthesis. Oh, actually, let's squeeze that x in there because like I have an x minus 0, which kind of means I don't need like a parenthesis around that. I just need an x and then x plus 3. Sorry, that's kind of smushy in there. Now, I do want to do the last example. I know you had to glue it down, but I think it's pretty simple to write it out on a free space in your notebook because there are going to be a couple of these on our assignment tonight. So taking a look at this one here, we talked about this before when we were in vertex form. If I want to take something that is in factored or intercept form and change it to standard form, this just means we want to follow order of operations. So this was kind of that one where we wanted to we're multiplying 3 things here and we can't multiply all at once. So we kind of multiply the 2 parenthesis guys by each other by doing FOIL or the box or distribute twice or like old school multiply. I'm going to FOIL real fast in my head. So like x times x is x squared. Then we'll have negative 6x and positive 2x for negative 4x. And then last we'll have 2 times negative 6 for negative 12. And then the other thing I can do is now multiply that negative 2 by everybody. So we'll have negative 2x squared plus 8x plus 24. And then I can't really do anything else because I don't have any like terms. And so there you go. A little bit easier than when we were in vertex form. All right, guys, so I'm probably going to post another short video where I do a couple more graphing examples on that other page here. So we'll see you in the next one.